hopefully you all have something kind of sort of like this, but maybe with less things. This is the Stevens Center, right? Some of you should have the seating areas for Friedman drawn, and some of you will have had the seating areas for Catawba drawn. So, any problems anybody ran into that we need to resolve?
I just have a question.
Yeah.
So, bottom of the seating area is on the floor.
Okay.
And then the top of it, is that the top of the chair or like the bottom?
So, good question. So when you're drawing these surfaces, you're drawing the floor. The floor of that surface. In other words, the bottom of it. So you would be, the height of that back row is the height of the floor level of that back row. Because then what happens is, as you'll see in a minute, when we actually start figuring out listener planes, the listener plane gets put up above it at the height of the ears of the people sitting there. And yeah, because if you think about it, well, the other reason that we draw it this way is obviously those seating units have steps, right? But we don't draw it that way, and that's just because if you think about the listener plane, ultimately the listener plane is not stepped, right? The listener plane is a flat surface if you're connecting all the ears of the people up there, And so we draw the floor as though it's just a flat thing, and then we can raise it up above there. Other questions or problems? Okay, so then how do we put listener planes in this thing?
You right-click on those faces.
There are a few ways to do it. The easiest way that I have found is if you can do what I was suggesting last week and actually draw surfaces that are made of 4 points, or vertices as they call them in ease, then it's very easy to just click on this one, for example. If I right-click on it and I just say area above face, and it creates an audience area automatically for you. And you can call it something if you want, something more interesting, but you can just hit OK, and there you go. And you just do that for every one of your audience areas. Right? And then you're good to go. And after I've done these ones, I'll show you what happens if you don't do it right. Okay, so I've now done all the audience ones. So what about, this one here? This is the stage. If I tried to do the same thing with that one, oh, it's grayed out. Why is it grayed out?
It's up. You got so many points.
Yeah. So it'll only audience areas can only be made up of 4 vertices or 4 points. So if the surface that you've drawn has more than 4, then you can't do that shortcut.
Is there any reason for that? Just
Probably.
processing?
I think it has something to do with, the way they calculate the coverage on top of it. But I don't really know. So if you want to make this an audience surface, you basically have to draw surfaces on top of it, which is really obnoxious. But so you have to kind of go over here, and you can do insert audience area, and you can kind of trace out a surface. So I could trace out that thing, and now I could make that an audience surface, right? If you wanted to, and you would have to go in and draw surfaces, all 4-point surfaces all across that in order to cover that whole thing. You can also just draw a regular surface over it, like this. And this is, I think, probably the preferred method. And then you say check this box, say this is a coat of, and then you pick, whatever surface that is. I think it's F10. No, F4. Right, so now I've got F11 that is coating the surface of F4. And F4 is a more complicated surface because it has these extra parts that I'm not in there. But now that I've got this F11 that is sort of like a coating on top of it, now I can go into that and I can say area above face. And then I can get my audience surface.
Is that a common thing to do, like make up the drafting errors, or like when people have been lazy and they've chosen to do more than 4?
I don't know. I mean, some of this goes back to, so one of the things that ease is trying to do is ease is trying to completely predict all of the acoustical properties of this room. And so if you are trying to do that, you're going to draw a whole lot of surfaces that are not audience surfaces. You're going to draw walls, you're going to draw steps, you're going to draw, ceilings and balcony, under balcony surfaces. I mean, all of these things you're going to draw. And for example, in Stevens Center, I would be drawing the aisles of these seating areas where no one's ever going to sit, but I'm going to draw the aisle anyway because it is a reflective surface, right? And so if you're going to draw that, a lot of what people do is because you have to create, in order for it to accurately predict some of the acoustical things it's trying to do, it needs a perfectly sealed room. They call it, a watertight room. So there's no holes in this room anywhere. And so you're going to draw like the whole floor of the audience area maybe by itself just to make sure that's one surface that has no holes. And then after you've done that, then you can draw audience surfaces on top of that are like coating surfaces. And you can do that without having to worry about connecting those dots and creating or sealing new holes, right? I think that's why this option exists. As to why they have to be 4 vertices, I have no idea. But that's the idea, is that say the people who are actually trying to draw the entire 3D room, all the surfaces, that's easier sometimes to just draw the big one entire wall, one entire floor, and then create the little audience areas on top of it. We are not going to do that because we really do not need all of that data. As you'll see when we get to the prediction stuff, there are all kinds of things EASE is capable of predicting. If you actually put all of the information in here, all the metadata, because you draw all the surfaces, define all of the wall materials, perfectly seal it up and everything, it can actually not only predict graphs and stuff of all this stuff, but it can also tell you what that will sound like. Like you can create, I suspect what it really does is it creates a virtual impulse response of the room and then runs that through some sort of convolution processor, which what that means in effect is that you could put it on a set of headphones and plop virtual listeners in the room, and it'll tell you what it will sound like in that room sitting in that spot, which is just crazy.
Have you tested that to see if it's accurate?
No, because I've never had the patience to put all of that data in.
What's the easiest space that we could draft? Toggle?
Patrons, probably. So anyway, it's this. What I'm getting at is this program is trying to do a heck of a lot more than what we're actually interested in doing, and so there's a lot of the weird kind of processes that it's asking you to do are in some cases connected to data input and output that you're never going to encounter, and that's why if you went through that tutorial and they talked you through that process of the face on top of the face and the audience area, that's what that's about, is if you're actually trying to do the whole room. We are very rarely, if ever, going to. The only reason you would ever get yourself in that situation is if when you leave here you go work for some sort of an architectural or AV consulting firm where you're consulting on new buildings that are going to be built. And if that's going to be your world, and if it's a really, really high budget project and they don't mind paying all of the hours for somebody to do the ease model, which very rarely are they willing to pay for that because it's a lot of time. But if they are, then yeah, you'll do all of that. You'll put in all that data, and then they can have pretty drawings, and you can do this really cool, conference meeting where you put headphones on everybody and say, "This is what your room is going to sound like if we build it," and they'll get very excited and have no idea that they've just paid you thousands and thousands of dollars to create that little prediction for them that doesn't actually change what they're going to do, because they're not going to change the building just because of how it sounds. Because that never happens. They're gonna build the building the way they want to build it, because it'll look pretty, and then you'll just have to figure it out, right? But anyway, that exists. All right, so once you have those audience surfaces defined, then you can now go in and start. Orientation of one. Old code is wrong. Oh, it doesn't like that. I need to just get rid of that. That's right. So delete. Delete. Okay, there we go. Now it's happier. Okay, so now we can start plopping loudspeakers in here, and we can show you what that process is like. So for Stevens Center, let's just sort of say we're going to put in a center cluster in here, a new center cluster. I've got the CAD file here. This is kind of the spot in the eyebrow where we can put things if we're going to do the center cluster. So I can look at that, and we can start putting things in there. So there's the coordinates. Somebody write this down. X is 12.3. No, wait a minute. This will be Y is going to be negative 12.3878, and Z is going to be 38.4719. Somebody got that?
Yeah.
Okay.
3.878 and 38.
Yeah, so it's going to be Y is going to be negative 12.3878, and Z is going to be 38.4719. All right, so how do I put a loudspeaker in here? Well, just like you have this tool to insert a vertex and a tool to insert a face, you have a tool to insert a loudspeaker. So you click on that one, and you can just click anywhere. It doesn't matter where you click, because you're never going to actually click on the spot where it's going to end up being, because you might get lucky, but it's not likely. So yeah. So I'm just going to click, and it's going to pop up this window, and it's going to say, okay, well, first of all, where is this thing going to go? What's our point of reference? So what is our X? 0, right? What is our Y? Minus 12 point something? 3878. And what is our Z?
38.4719.
Okay, so that's where it's going to go. And now what I need to know is what loudspeaker am I going to do? So here, if I click on speaker model, it brings up this thing. And these are loudspeakers I've already imported into the project. These are the ones that are currently in the space. So we can model those if we want. But we can try something else as well. So if we go to this Browse button, so Ease ships with a whole bunch of loudspeaker directivity files that I guess they go and get from manufacturers and stuff. You can install your own. You can download them if you want. But if you go to, it should default you to this folder, Global Speakers. And here's all these different manufacturers. So what's a loudspeaker that you're familiar with that you think might be interesting to try here? Well, I already have that in there. So what's something else?
Control 25. Yikes.
Okay, yeah. So, I mean, that's probably not going to work, but because it's just too small. But sure, what the heck? I believe you'll find that in recording. Those are Control 1. No. Let's see. see, control 25, there it is. So I can click on that one and just add it into the project. And then I can hit close. And now it's in my list of ones for my system. So I can select it there, plop it in there. And the first thing you kind of want to do is click this little button that says all to max, because it has information about maximum SPL levels for the loudspeaker per frequency. And if you just click that, it will automatically adjust everything so that you're putting out by default the max that the loudspeaker is able to do. And then later you can attenuate that. But if you do that all to max, notice that it has different levels. And you can see there's a graph here showing the essentially frequency response on axis of this thing. If you do flat max, it will flatten out artificially the loudspeaker, which I would recommend not doing, because part of what you're trying to figure out is what naturally, how will this sound be dispersed based on the natural sensitivities per frequency of the loudspeaker. So you don't really want to put it flat. You want to see what it actually is going to do. And then once you're there, you're pretty well good to go. The only thing you may want to do is label this, because it's going to say just some weird S1, but I'll do something else. I'll say center cluster underscore test. We'll just see what this does. So I hit apply, and there it is. There's my little control 25. So now at the moment it's just shooting straight out. Okay. Which is probably, there's this cool little view you can go in. If you right click on it and go to loudspeaker aiming, you can like stare down from the point of view of the loudspeaker. Hey, where are we going here? So it looks like if it's just shooting straight out, it's aiming somewhere, it looks like 4 or 5 rows down from the back of the balcony. So what the heck, we can leave it there. And you can also just click around in here and move it if you want. But let's just see what happens if I try to plot this now. So I'm gonna hit this little Save Project Data button, and that dumps that information over here into the main project. And then I go to Calculations, and there's 2 options here. You've got Area Mapping or Room Mapping. Room Mapping is what you would use if you wanted to create something pretty. In other words, something that has like a cool 3D view from an angle that would make somebody really interesting and exciting. I think that's kind of not useful, because I would rather see meaningful data than pretty data. So I would prefer area mapping, and what area mapping does is it just takes all of the surfaces that you have drawn and it just kind of stretches them out. Let's see if I can, there it is. So it kind of stretches them out so you can kind of just see them. Well, it should have pulled the balcony out. Let me see if I can. I'll show you room mapping. So room mapping gives you this kind of view where it's like some sort of weird 3D rendering, which I think is not real helpful. So area mapping is, I think, more helpful to me. Although, like I say, it should have pulled that out. Let's see if I can. Well, anyway, so what I'm going to do now is you have all of these, this little row toolbar here are all the different things you can plot. Okay. Most of these are things you're not going to do. So there's like STI, which I believe stands for Speech Transmission Index. There's ALC, articulation loss, and what they call ALCONs. There's all of these, clarity. There's this thing called total SPL, and if you've actually drawn all the walls, it will plot onto the audience surfaces the actual sound that will hit there, including reflections. Again, we're not going to do that. The one you're going to spend most of your time in is this thing called direct SPL, and this is just direct sound from loudspeaker to listener. what are they going to hear? And that's helpful. There's this other one we'll play with later, these first arrival and first pause. This allows you to plot time, which is kind of interesting. We will play with that a little bit. It'll actually, again, this is assuming you have the walls, but it'll plot critical distance. It'll tell you where your critical distance is when you cross that line of, as we've discussed, critical distance. There's also, it'll plot direct reverberant ratio across the entire area. Again, you have to be able to predict reflections in order to do that, so you have to draw the walls. But that's helpful if you're trying to figure out acoustically what's wrong with the space. So there's lots of interesting things. There's this other one called loudspeaker overlap, which is kind of cool. It doesn't show, it's not sound pressure level, but it does show you the extent to which the loudspeakers overlap, where they overlap. It doesn't tell you the result of that, but if you are trying to deliver on that notion of I never want loudspeakers to hit the same place in the same, at different times in order to avoid comb filtering, this can kind of help you see that. But at any rate, let's do direct SPL, just for fun. So I'm going to click that, and it's going to ask me for some information. So the first thing I need to tell it is which loudspeakers do I want to plot. So loudspeakers in use currently, it says none. And so I'll click on that, and my only one in the list is this one that I've added. So I'll just select that, click OK, and now it says, okay, center cluster test. And there's other things that you can put in here. For example, under calculation, you can do an interference sum where it will attempt to show you destructive overlap between loudspeakers. So it'll try to show you the results of comb filtering. We're not going to have that problem here because we only have one loudspeaker, which is why most of those options are grayed out. And if we tried to plot that, we wouldn't really get a whole lot. It's interesting. You can actually introduce an artificial noise floor, and that'll help in some plots, some of the clarity and things which we're not doing. You can also tell it which audience areas you want to plot this on. I'm going to just do all of them for now. We'll click OK. And here's what will happen. It'll think about it for a minute. And there we go. This is for 1 kilohertz. So right now it's not plotting on the balcony. It's just showing me the orchestra area. And you'd think that this looks pretty good. You've got a key over here, which is direct SPL in 1 dB increments, and we're pretty much in the blue everywhere. So you might think, wow, control 25, who would have thought? That's actually covering really well. However, remember that button we clicked when we inserted it into the space, and I said that all to max thing, which means this thing is putting out the maximum sound pressure level it's able to do, and it's hitting the orchestra area at 69 dB, which is not particularly loud. I'm talking louder than that right now. So yeah, it's covering pretty evenly, but you have zero gain, right? So not particularly helpful. But just for fun, let's go ahead and let's see what's going on. So if I plot a different frequency, I click on this 1,000 hertz, I can go to 4,000 hertz, and then I'll hit this little render map thing again, and it'll kick it over there. Again, for 4K, that's not bad, right? But 4K is sitting down here, most of the cases down at 58, 57 dB. So maybe not so helpful. So what if I wanted to make it a little bit more helpful? Well, I could re-aim it a little bit. So if I go in here and actually point it towards that audience area, so maybe let's take it down, and I'll point it down towards the back row here. Yeah, maybe. So I've just pointed at the back row orchestra, and I'll need to hit this save data so it'll dump it back into the project. And now I can re-render this. Let's see what we get. So you see where it gets this little yellow thing? That is telling you that there's a problem. You need to acquire the new project data. Because remember, this is just a separate app. It doesn't necessarily know that I moved the loudspeaker, okay? Let's click OK. It says yes. Great. Now replot it. It should show us the difference. Okay, so pointing it down got us an overall increase in level by a few dB. And it looks really great, right? Super even coverage. But pretty quiet overall. The other thing that I would notice is that when you get to the walls and the front row, it hasn't really gotten that much quieter, and that would lead me to believe that it's probably going to be spraying a lot of sound onto the stage as well, which I would not really want. So from a perspective of throwing a long distance, this is maybe not the best idea because it can't get very loud and it's not very well controlled, even at 4 kilohertz. Yeah.
When you do this, before you get into ease, if you're expecting like a sound cluster in space, would you do what we did, like with the section and AutoCAD, and be like, hey, this is the angle that I need for the seatings on
Yeah, I mean,
the section of the ground plan, or would you literally just like toss it around in ease first?
it's a little bit of both. I mean, to some extent, you know, you're going into ease and you can pick one of thousands of different types of loudspeakers. So, I mean, you don't want to just be randomly picking things. In some case, like in our case, you know what loudspeakers we own. So that's going to like narrow the field right out of the gate, right? You're not going to spec something that isn't in our shop. But you also do want to think a little bit about, well, what do I need it to do? And you know from the CAD file the area you're trying to cover. So you can kind of get a sense of what angles you're looking for as far as coverage.
Yeah, but you would probably do that first. Just to
Yeah.
like,
I wouldn't necessarily do the directivity math, but I would at least go into the CAD file and just say, you know, well, if I'm putting something there and I want to cover, you know, this audience area here, what kind of angle am I looking for, right? And, you know, that could be, let me make this a little bit bigger here. And I'm looking at that going, it's a 52-degree angle. You know, from a vertical coverage point of view, if I cut that in half, given our rule of thumb of trying to aim on axis to the back row, I'm really looking for something with 100-degree vertical coverage. There aren't a lot of loudspeakers out there that do that. So that's going to tell me right away that I'm probably going to end up with a vertical cluster here in order to really hit all of this. Because that doesn't include the balcony. I have to figure out the balcony as well. So you can kind of start thinking about those kind of angles. You know, if I go to the back row balcony, front row balcony, again, I'm just really roughing this in here, and I measure that angle. You know, that's 18 degrees. So okay, so I'm looking at something about a 40-degree vertical. Okay, so what's something that you know that has about a 40-degree vertical? I mean, let's actually try and tackle this balcony area. Something besides the thing that's already there. The first thing I'm going to do is, just to help me here, I'm going to go in and label these audience areas. So this is house left balcony. This will help me identify them when I get in there. Oops. So start thinking about what loudspeakers do you know that we have in our shop that have a 40-degree vertical coverage. I'm browsing. What do you want? What do you think? So we're looking for 40. We've got a lot of VAW stuff in the shop. Let's look in there. Here's a JFX. We've got 260s and 290s. What's the vertical coverage of those things?
Oh, hey, 45.
Hey, that might work. So let's try. So for the balcony, what do you think? The difference between the 60 and the 90 is 60-degree horizontal versus 90-degree horizontal. So from that spot to the balcony, what do you think is the most likely, the 60 or the 90? Again, trying to keep it off the walls as much as possible.
It depends.
It does depend. But let's just go ahead and pull both of them in, then we can try them both. All right, so I'll try the 260 first, because I know that's the narrowest one. And I would err on the side of what's the narrowest we can get and still cover the audience, because that's better, right? The less sound on the walls is better. So JFX 260, I'm going to redo the all to max. Now, hey, look, peak SPL on this thing's 110 dB. A lot better than that Control 25. So there it is, and I'm going to go ahead and aim this sucker back up to the back of the balcony. Save that, and now let's go to area mapping. And I'll hit my direct SPL, and there's my center cluster, and for audience areas, I'm going to select the 3 balcony ones. See that? So that way I can plot on that plane. So I can hit OK, and it's going to think about that for a minute. And there's 4K. Now, that looks pretty. But let me show you something that I think is a bit more useful. This little button called ISO lines. If you click that instead of this other one, these patches, what that does is it actually draws lines, and those lines represent 1 dB increments. That's helpful. Because if I'm trying to make sure that I'm staying within 6 dB, I can count those lines, and I'll know it once I have more than 6 lines, I'm done. Okay. So how are we doing? Here's 1 dB, 2, 3, 4, 5, 6. Hey, I'm close, right? Got 85 in the center and 79 here. We get to 78 in the corners, so that's maybe not as good. We're at 86 dB SPL at max. That's okay. Ideally, we'd like to be a little bit louder than that, but this is 4K as well. If we look at, let's go down to 500 hertz. Plot that. Oh, sorry, I got to hit the recalculate. There you go, there's 500 hertz. So I'm well within 6 dB at 500 hertz. I can now look at 1K, recalculate that. So what are some things I could do, you know, if I go back to that 4K, which is the hardest one usually to really get good. What could I do to make this better? Yeah, I might be able to tip it up a little bit. Let's see what happens there. So I mean, I'm already pretty high, but let's aim it up here, which is kind of the back row of those side sections. And let's see if that helps at all. I wouldn't want to go a whole lot higher than that. That helped a little bit. So now I'm 84 here, and I get out to 79 here. That's within 6 dB, isn't it? So that could work, right? It's not bad. Now, what if I swap this out for the 290 just for fun? Save that. Come back here and say acquire the data. And it's going to recalculate. Let's see what changes here. Well, as expected, the 290's wider covers because it's got that 90-degree horn on it, and yeah, that's not bad, right? Now the downside there is I'm hitting the walls pretty hard, and right over here, so you're gonna have to make a choice there. What do you want more? But that's an option for sure. So this can kind of help you figure this out. Now maybe I say, well, all right, well that's good, but maybe there's something better. If we want it, let's try the one that we know is hung there, which is a D&B Q7. If it's like a bad file, maybe. Like a bad loudspeaker file. There's something wrong with your drawing then. We'll look at that in a minute. So this one I need to rotate it 90 degrees because that's how it's deployed right now. So let's put that in. Let's see what we end up with. So there's my 4K. In this case, now I can probably tip this down further. It's just it controls a little bit differently. So I can go back here and re-aim this thing. So you can kind of see the process here. The mistake I see a lot of people make is that they'll say, well, they'll decide what they want to do, and then they'll just go to all this work to make an ease file that shows that thing they've already decided. And that's really kind of backwards. The whole goal here is for ease to help you make that decision. It's much better if you can certainly get a few ideas of what needs to happen, like basic angles and stuff like that, but then try some different things and try to figure out which thing gets you the best result. And if you look at this aiming thing, these little lines represent 3 and 6 dB down. So I can actually get away with tipping this a bit more if I want to cover this area better. So if I put it right there, let's see what happens. I might have gone a little too far down, but you can kind of see the difference here. And this is at 4K, which is pretty good. You understand the basic idea here? Okay, so what I want you to do now in the next, we still have that little, almost 40 minutes left of class. I'll turn mine off, so we should have enough licenses then. And you can all take a moment and start putting your loudspeakers in. What I'm really looking for you to do at this stage is literally just redo what you did before on paper. Just go find those loudspeakers that you spec'd, put them in there in the exact kind of configuration that you did them before, and see what it looks like, see how it plots out. And then once you do that, then you can kind of say, well, how could I tweak this to make this better? But start by just doing what you did before. Put them in. So you can do that now, which is, by the way, the assignment for Friday. Is come in here with your loudspeakers that you spec'd, put in there. And by the way, you can put both of them in, right, at the same time, and then when you plot them, you can just pick which ones you want to plot at any given point in time. So you could, because you each did 2 different options, right, for that last project. So you could install both options in there, and then when you go to plot the coverage, just select which ones you want to plot at any point in time, and you can see the difference between them, right? So you don't have to have 2 separate files for your 2 different ideas. Okay, so I'm going to shut mine down and turn my license in. We still have one ease license that I haven't tracked down yet, but I think I've got an idea where it is. So I'm going to check on that this afternoon and see if I can fix it.
Can you get lost?
I don't know, but